to talk about logarithmic functions, logarithmic equations. Okay. When somebody writes log base A of B equals C, that has no meaning to you. Now I'm going to tell you what it means. It means A to the C equals B. A to the C equals D. Now when you see things like this, you know what it means. This is called logarithmic form. And this here, logarithmic form, because it has logs in it, the word log, and this is exponential form. And for now, we're going to convert back and forth. Log base 2 of 8 equals 3. What does that mean? It means 2 to the 3 is 8. 2 to the 3 is 8. Log base 4, log base 3 of 81 is equal to 4. So write it exponentially. 3 to the 4, which is 81, equals 81. 3 to the 4th equals 81. You must know how to go backwards and forward. You must know how to go backwards and forward. I told you log base 3 of x plus 4 is equal to 5. Well, this means 3 to the 5 equals x plus 4. Three to the 5, if I'm not mistaken, is 243. I can even tell you what x is. X must be 242. 242 plus 1 is 243. But that's a whole nother story. Writing it exponentially, we're done. 3 to the 5 equals x plus 1. Now, a little notation. A little bit with the notation. Shorthand notation. When you see log of some number, that is, you don't see a base, it's understood to be 10. It's understood to be 10. That is, what would log of 100 be? Well, you should think log base 10 of 100. And then you ask yourself, 10 to what power gives you 100? And the answer is 2. 10 squared is 100. Whenever you see log of a number, it means base 10. We won't know this number offhand, but a calculator can tell us. 10 to some power is 73. Whatever that power is, that's what this equals. That's what that equals. There's another notation. It's called the natural log. Natural log. For some reason it's written backwards. ln. ln of A. It means log base E of A. E is some special number. E is equal to 1 plus 1 over n to the n as n goes to infinity. That's what E equals. If you take 1 plus 1 over a very, very large number, 100 million, and you raise this to that same large number, 100 million, you would get approximately E, which is approximately 2.718. But it's a constant. Just like pi is a constant, E is a constant. You don't have to remember this. E is approximately 2.718. But don't ever use that anyways. Use E. Your calculator has an E button. Your calculator has an E button. And has an element of E button, probably right above it. E is E. You deal with pi a lot of times, but you don't remember what it has to do with a circle. Okay, so now we're going to convert backwards. Remember that log base A of B equals C is the same as A to the C equals B. So if you're given 2 to the 3 equals 8, well, A is 2, C is 3, and B is 8. So just live up to that. A is 2, A is 2, A is 2, B is 8, so I write B next, B is 8, equals, C is 3. And you can check 2 cubed really is 8. We know that A to the C equals B means log base A of B equals C. So if they tell you x plus y to the z is equal to (10x plus 9), well, A is x plus y, C is z, and B is 10x plus 9. So it's log base A is x plus y, B is 10x plus 9, equals is equals, and C is z. Log base x plus y of 10x plus 9 equal to z. And I can double check what I'm about to say better be what's on the left. X plus y to the z should equal 10x plus 9. And that's exactly what this equation says. So it's not math at all. It's not math at all. You need to know this. Fine. If you want to call that mathematics, fine. You have to know this. But once you know this, it's not math. This is A at this location. This is A. This is where B is, and the exponent is C. So you write A here, and B here, and C there. You write the word log in front, and you put an equal sign. You're just writing things differently. Why does it work? Because it was defined that way. Now, there are a couple of rules that we should know and have at our command at all times. What is log base A of 1, regardless of what A is? Remember, A to the 0 should be 1, and it's 0. Anything, including A to the 0 power, is 1. Okay, so that's one rule. Log base A of 1 is always 0. If you have log base A of A, what should that equal? Well, A to what power gives you back A? A to what power gives you back A? 1. A to the 1 is A. So if you take log base A of the same thing, you get back 1. Okay, what if I modify this a little bit and call it x? A to what power? A to what power equals a to the x power? I would hope the answer is obvious. A to the x equals a to the x. A to the x equals a to the x. So this is just x. And these are some rules that you should know. And we'll keep them up there, and we'll work out some additional problems. How much is log base 5 of 5 to the 4? Well, if I number these equations 1, 2, and 3, it looks like rule 3. But again, you don't even have to remember rule 3. 5 to what power give you 5 to the 4th power? The 4th power. 5 to the 4th power really equals 5 to the 4th. Log base 3 is 3. Well, this is like rule number 2. These two are the same. But you don't have to remember the rule. Just work it out. 3 to the 1st power. 3 to the 1st power gives you back 3. Log base 2 is 32. This is asking 2 to what power is 32? A lot of students say, well, I don't know. Fine. You don't know. Not a problem. 2 is 2. 2 times 2 is 4. 2 times 2 is 3 times is 8. 4 times will be 16. 5 times will be 2 times 16, or 32. 2 to the 5th is 32. 2 to the 5th gives you 32. You can't know every answer. I certainly don't. But work it out. Maybe I didn't know what 2 to the 5th was, but I still was able to do this problem. So can you? But you have this one. Log base 3 of 1 over 81 equals what? This is asking 3 to what power gives you 1 over 81? Well, if you think about it, 81 is 3 to the 4th. So 1 over 81 is 1 over 3 to the 4th. But 1 over 3 to the 4th is 3 to the negative 4th. That box should be negative 4. Then this clearly equals that. They look exactly the same. So the box is negative 4. That is, what does this equal? Negative 4. Somebody asks you, what is 7 times log base 3 of 1 over 81? But right now, you should say immediately, oh, that's negative 28. Why? Most people don't know this, including myself, but we just worked it out. What's in the brackets is negative 4. 7 times negative 4 is that number. Don't panic. This is just a silly way of writing negative 4. If I ask you, what is log base 3 of 1 over 81 plus 10? You should say 6. Negative 4 plus 10 is 6. This is just negative 4. It's another way of writing negative 4. Are you going to remember that tomorrow? Probably not. But for this problem, we know it's, for right now, we know it's negative 4. Log base 4 of square root of 2 is what? Well, this is saying 4 to some power is equal to 2 to square root of 2. That is 4 to some power is 2 to the half power. 4 to some power. Now remember, 4 is 2 squared to that unknown number. But that's 2 to the 2 times the unknown number, which is equal to 2 to the half. That is, these two are equal. 2 times some number is equal to a half. Think of that box as x, or y, or z. For some reason I'm writing box, but it doesn't matter. Divide by 2 when you get the box. An alternative for dividing the right side by 2 is to multiply by the reciprocal. It's friendlier to multiply by the reciprocal than to divide 1/2 by 2. In either case, we get a quarter. So the answer is a quarter. 4 to the 1/4 power is equal to the square root of 2. How do I know that? Because I know the 1/4 is half times half. Why did I even mention half times half? Because I know what 4 to the half is. 4 to the half is 2. 2 to the half is square root of 2. Okay, sometimes they'll be less obvious. Instead of box, you can write x log base 4 of square root of 2 equals x. You have log base 3 to the 1/9. You can say it equals x, so 3 to the x is equal to 1/9. But 1/9, or 9, is 3 squared. So this is 3 to the negative 2. Well, if 3 to some power is equal to 3 to the negative 2, then x must be negative 2. X must be negative 2. That is, log base 3 of 1/9 must be negative 2. And we can check it. 3 to the negative 2 should equal 1/9. Well, that's the same as 1 over 3 squared, which is 1 squared over 3 squared, which is 1/9. It did check. Somebody were to ask you, what is ln of e to the 4th? Remember that ln is shorthand for base e of e to the 4th. This is asking, e to what power gives me back e to the 4th? 4. E to the 4th power equals e to the 4th power. How friendly of a solution that was. Suppose you had log base 4 of 8. What is that equal? Now that's a hard one. 4 to the 1 is 4. 4 to the 2 is 16. All I know is the answers between 1 and 2. Well, let's work it out exponentially. 4 to the x is 8. Now, these bases are not the same. I can't get 8 to have a base of 4. I can get 4 to have a base of 8. But 4 and 8 I can write with a base 2. Remember, this is 4 to the x. 2 squared is just another way of writing 4 to the x. And 8 is 2 to the 3 power. So the left one, remember, you multiply exponents. We get 2 to the 2x is equal to 2 to the 3. You have to raise 2 to the same power to get equality. That is, 2x must be 3. Divide by 2, x is 3 halves. 4 to the 3 halves power. 4 to the 3 halves power is 8. Let's check that. 4 to the 3 halves power. That 2 is what to deal with first. 4, what times itself? 2 times gives you 4? 2. What times itself? 2 times gives you 4? 2. Now cube that answer. And you get 8. To review again, if you had 16 to the 3/4, what times itself 4 times gives you 16? Well, 1 times 1 times 1 times 1 is 1. That's too little. 2 times 2 times 2 times 2. Oh, that's 16. So this is 2 cubed, which is 8. The answers are not always 8. The answers are not always 8. That'd make life easy for us, wouldn't it? What's the answer? 8. Okay, so if I ask you, for example, to solve for x, log base 2 of x is 3. What does x equal? Very routine. 2 cubed is 8. 2 cubed is x, but 2 cubed is also 8. That is 8 equal x, x equal 8. If I gave you log base 5 of x equal to the 4th, x would be 5 to the 4th. 5 to the 4th is x. For 5 to the 4th, if I'm not mistaken, is 625. If I told you log base x of 9 is equal to 2, well, this says x squared equals 9 and x is positive. X squared equals 9, so x is 3. What goes here has to be positive. If I told you log base x of 10 is equal to 7, well, we know x to the 7 is 10. Well, if I raise both sides to the 1/7, on the left I get x, because 7 times the 7th is 1. And on the right side, I get 10 to the 1/7, or the 7th root of 10. That's what x equals, the 7th root of 10. So if somebody were to ask you, what is log base the 7th root of 10 of 10? You should say 7, because we just worked it out. Assuming we're not wrong, what goes there is the 7th root of 10, what goes there is 10, and what goes there is 7. But that's exactly what I wrote. Now, these log graphs are very similar to exponential. In fact, you can convert backwards and forward. log base A of x equals y, this means a to the y equal x, or x equal a to the y. Well, this is very similar to what we've done before, except x and y were changed. Here we have y equals a to the x, and here x and y are interchanged. Okay, well, if x and y are interchanged, what you need to remember is, hold on a moment. What you need to remember is that x and y are interchanged. For example, you know that this is y equal a to the x. Well, it's getting close to the x-axis. Excuse me. Horizontal asymptote is y equals 0. And when x goes to negative infinity, y goes to 0. And when x goes to positive infinity, y goes to infinity. Well, these get reversed. These get reversed. You now have x equals 0. As y goes to negative infinity, x goes to 0. I'm interchanging the x and the y. That is, right here I write y. Right here I write x. As y goes to infinity, x goes to infinity. And so that's here. If you were to graph this, let's see what happens. It's going to have the same flavor as y equals a to the x. We know that it gets close to x equals 0. That's x equals 0. We know that when y goes to negative infinity, when y is very, very negative, x is close to 0. When y goes to positive infinity, x is really large. The graph goes like that. This is x equal a to the y, also known as log base a of x equals y. Okay, or it goes like that, depending upon whether a is bigger than 0. I meant to say bigger than 1. A is bigger than 1, and for this graph, a is less than 1 but positive. It's one of those two graphs. It's one of them. So, when you write it exponential and the power is y, those are the two new graphs that you might get. When you have x equal a to the y, you either get this or you get that. If you have y equal a to the x, either you get this or you get that. You get one of those four. Okay, so now, if you're asked to graph some functions, to graph y equals ln, log base 3 of x. If you're asked to graph this, you graph 3 to the y equal x. 3 to the y equal x. And like always, let the exponent be 0 and 1. Let the exponent, y, be 0 and 1. Well, when y is 0, 3 to the 0 is 1, and that equals x. Because whatever 3 to the y is, that's what x equals. 3 to the 1, or 3, x is 3. And I graph it. When x is 1, I go up nothing. Y is 0. When x is 3, I go up 1. Right here. And I have to get close to the y-axis. There it is. There's your graph. Perfectly drawn. 2 points. 2 points. 1, 0. 1, 0. 3, 1. Intelligent point. Let the exponent be 0. Let the exponent be 1. Suppose you were asked to graph y is equal to log base 2/3 of x. Well, I'm not good in graphing exponential functions, for real. I convert them, I meant to say logarithmic. I convert them to exponential. This is saying 2/3 to the y is equal to x. Okay, I can graph that. I let the exponent be 0 and 1. That happens when x is 0 and I meant to say when y is 0 and y is 1. And that's the 2. Okay, 2/3 to the 0 is 1. That is, x is 1 when y is 0. When y is 1, x equals 2/3 to the 1, or 2/3. Okay. When x is 1, I go up nothing. When x is a little bit less, like 2/3, I go up 1, right here. And I have to get closer to the y-axis, which tells me that my graph goes like that. Don't touch the y-axis. Get closer and closer to it. Here's the y-axis. Get closer and closer to it. Never touch it. Let's try some of these. Remember, another name for y is f of x. Another name for y is f of x. So suppose you were asked to graph f of x is equal to log base 2 of x minus 4. Suppose you were asked to graph this. Remember, that's just y. So 2 to the y equals x minus 4. 2 to the y equals x minus 4. Okay, vertex. What makes this 0 is 4. And what makes that 0 is 0. I take that back. So bring the 4 to the other side. So x is equal to, I guess this is the same, sorry. What makes this 0 is 0, so y is 0. And what does this say? 4. So whether you do it from here or here, we got the same vertex. Okay, so let's draw this. 1, 2, 3, 4. It's as if the new origin is right there. That is, think of this as the y-axis, and think of the x-axis as the x-axis. Okay, so we want to graph x is equal to 2 to the y plus 4. Like I've always said, let the exponent be 0 and 1. And that's going to happen when y is 0 and y is 1. Well, if y is 0, 2 to the 0 is 1, plus 4 is 5. If y is 1, 2 to the 1 is 2, plus 4 more is 6. So when we have some points, when x is 5, I go up 0, and when x is 6, I go up 1. Now remember, those are my two axes that I'm going to think of when I draw this. I have to get closer and closer to the y-axis, the new y-axis. All right, there's my graph. Okay, it'd be nice if I understood why that didn't graph. Does anything graph? That graphs. And now it's graphing. Okay, there's my graph. Okay, not this here. There's the graph. You can graph this exponentially, but I don't like to graph exponential graphs. I like to graph logarithmic graphs. Excuse me, I take that back. I don't like graphing logarithmic functions or graphs. So I convert them to exponential graphs. Because that I know how to draw well. I never thought there was a need to learn how to graph logarithmic graphs. I easily convert them back to exponential, and then I draw that. Let's just try one more. Suppose we're asked to graph y is equal to log base 2 of x plus 1 plus 4. Okay. First, you need to bring the 4 over. Y minus 4 is log base 2 of x plus 1. Okay, I'll change it to 1. X plus 1. Now, you could get out of logs. You can say 2 to this power equals x plus 1. You can say 2 to the y equals x plus 1, because what happened with the 4? The rule has always been, if you have log of some base of something equals something else, then you could rewrite it. But nobody said anything. Like if you have log base A of something plus something else equals C. No. You have to bring the C over. You have to have log, a base, of something, and nothing else. You can't equal something else. You can't have plus 2 or plus 4. Okay, so 2 to the y minus 4 is x plus 1. Bring the 1 over as minus 1. X is 2 to the y minus 4, then take away 1. That's the graph that we're going to draw. So we let the exponent be 1 and 0. The exponent depends on y. To get this exponent to be 0, I let y be 4. 4 minus 4 is 0. 5 minus 4 is 1. So I'm going to let y equal 5. Okay. When x is 4, 4 minus 4 is 0. So we have 2 to the 0, which is 1. Take away 1, which is 0. If y is 5, 5 minus 4 is 1. You have 2 to the 1, which is 2. Take away 1 is 1. Okay. When x is 0, y is 4. And when x is 1, y is 1 more. Y is 5. And the vertex is x value is, what does this say? -1. And what makes that exponent 0? 4. So the vertex is at -1, 4. It's as if this is our origin axis. And I have to cross these 2 points, so I go like that. And again, you get closer and closer to the exponent, which is y. You get closer and closer to the new y-axis. There's your graph. Okay, that finishes graphing logarithmic and exponential functions. Or just logarithmic, excuse me.